Good morning, students. Today I will explain two questions in Unit 1. First one is addressing modes in 8085 microprocessor. Then second question, instruction classifications based on length. So these are all the two 5-mark questions. First introduction, what is addressing modes? In addressing modes, all instructions has to operate on a data. In 8085, there are several instructions are there. The instructions has to operate on a data, all the instructions. The next, the way of specifying data to be operated by an instruction is called addressing modes. Before in it, all the instructions has to be operated on a data, but the way of specifying data to be operated by an instruction. The data to be operated by an instruction, simply we call it as what is the data to be operated by an instruction is called addressing modes. Okay, so this is called addressing modes. Then next type of addressing modes. There are 5 types of addressing modes in 8085. First one is immediate addressing mode, second one direct or absolute addressing mode, third one register addressing mode, fourth one register indirect addressing mode, then last one implicit or implied addressing modes. Now I will explain one by one what is immediate, what is direct addressing mode, what is register indirect, and finally implied addressing mode. Go to next slide. First one is immediate addressing mode. Here in immediate addressing mode, the source operand is always data. What is the source operand is always data. Here there are 3 examples are there. First one is move immediate b comma 45. Here the source is 45, source state, and the destination is b register. Whereas in immediate addressing mode, compulsory the source operand is always data. Okay, so 45 is a data operand data which is moved immediate to b register. That is the meaning. Some other examples for add immediate data, ADI data, add immediate data. So data will be presented on the immediate addressing mode. That is, then one more is subtract immediate, then AND immediate, ANI data, then ORI data, XRI data. So these are all the some immediate addressing modes. Then second one, LXIH C050. Before the data will be, the source operand is always data, but in second one the source operand is 16-bit address, that is C050. Here to load the HL pair with the operand C050 immediately. Okay, in the HL pair register to load the operand from C050. Okay, the address will be copied. Next, jump to the operand address immediately. Jump and address. Here there is no operand, so it will call the jump instruction immediately. The operand address is uh, jump over, that is the branching of instructions. So this is called immediate addressing mode. Next one, so this is the second category of 8085 addressing mode. One is, that is the name is direct or absolute addressing mode. Here in direct addressing mode, the data to be operated by available inside a memory location, and that memory location is directly specified as an operand. Here you see that in example LDA 2050 LHLD in 35. The first one is LDA 2050. Here the instruction and the memory location is directly specified as an operand. So this is called direct or absolute addressing mode. Direct, the every instruction in absolute addressing mode, the address will be specified directly. Okay, the memory location will be specified on the instruction, and then the operand is directly available in the instruction itself. Operand also available in the instruction. The last one in 35. Read the data from input port whose address is 10. Sorry, whose address is in the input port. Okay, so LDA 2050. Load the content of memory location into the accumulator A. So load the content of memory location into accumulator A. Okay, this is the 16-bit address. So directly you load the memory location, that is low order for 50, then I for 20. Okay, 2 8-bit address. This is called direct and absolute addressing mode. The next one, register addressing mode. Here in register addressing mode, data to be operated is available inside the register. Sometimes the registers are operands. So this is the meaning. The data to be operated by register. Okay. Therefore the operation is performed within various registers of microprocessor. Suppose we take one example, move A comma B. Move the content of the source register is B, the destination register is A. So source register to destination register, that is B to A. Move the content of register B to register A. And the next one, add B. Add B means content of accumulator plus content of B register. So add content of register A and B and store the result again in A. So in the register addressing mode, the data to be operated available by the register or register operands. The next one, increment of A. Increment of A means the content of accumulator will be incremented by 1. So these are all the some register addressing modes. So compulsory the instruction as uh, contain a register, then operand data also. The register operands are available to the register addressing mode. Next, yes, the third one, register indirect addressing mode. Before in absolute addressing mode, the data to be operated is available inside a memory location, and the memory location is directly specified by the register. Here in register indirect addressing mode, the data to be operated is available inside a memory location, and that memory location is indirectly specified by a register pair. Before directly specified by a register pair in direct addressing mode. Here in direct addressing mode, the memory locations are indirectly specified. For example, move A comma M. Here the move the content of memory location pointed by the HL pair to the accumulator, because the M is specified, M is denoted as HL pair register. Okay, so here the memory address is indirectly specified. Before the memory address is directly specified, that is LDA 2050. Here the memory address is directly specified 2050 for load in the accumulator. Here the memory A comma M is memory. The memory is represented as HL pair, so it is indirectly specified. Second one, LDAXB. Here move contains BC register to the accumulator. B for BC register, it is a pair register, so it contains move contains of B register to the accumulator. Okay, the next one, LXAH 9570. Load immediate HL pair with address of the location 9570. load immediate HL pair. You can load the data from 9570, that is pointed on HL register. Okay, this is called register indirect addressing mode. Then last one, implicit or implied addressing mode. Here the operand is hidden and the data is to be operated is available in the instruction itself. Okay, here there is no any operand, but it operate available within the data available within the instruction itself. Okay, so this is the different. For example, CMA, that is complement accumulator. It's complement, once complement of the contents of accumulator A in A. Again, first it complement of A, finally the result again stored in accumulator. That is the meaning. RRC, rotate accumulator A right by 1 bit. Similarly for rotate left circle, rotate accumulator A left by 1 bit. Okay, so these are the implicit or implied addressing mode. Okay, next question. Instruction classification based on length or word length. In 8085 there are three classifications: 1 byte instruction, 2 byte instruction, and 3 byte instructions. Okay, each instruction has two parts. One is operation code, another one is a opcode. Okay, opcode and that is an opcode or operation code. Then another one is in a operand. So here the instruction is depending upon the size of the size. Okay, so first one by one, what is 1 byte, what is 2 byte, and what is 3 byte. What is the first one? 1 byte instruction. In 1 byte instruction, the opcode and the operand in the 8 bits only. What is in 1 byte instruction include the opcode and the operand in the 8 bits only. Suppose there are three examples are there. Move C, A is a 1 byte instruction, and add B is a 1 byte instruction. CMA, complement accumulator, is 1 byte instruction. Here in move is a opcode. Yes, in 1 byte instruction is represented one part is opcode, another part is operand. So move is for opcode, operand for two register, that is B, source register and destination register, is called operand. The operand, the hexacode for operand is 47. The binary code for hexacode 4 is 0100, 7 is 0111. So this is the symbolic representation of move B, A. So this is known as 1 byte instruction. So simply 1 byte instruction is 8 bits only, which is 1 byte instruction. The next, 2 byte instruction. In 2 byte instruction is the type of instruction in which first 8 bits indicate the opcode and the next 8 bits indicate the operand. So there are two parts is there. One is opcode, another one is the operand in every instruction. But in 2 byte instruction, first 8 bits indicate the opcode and next 8 bits indicate the operand. Here there are several examples are there. Move immediate A, 09. So 09 is a operand. It represents 8 bit. Then another operand is there, A, that is also 8 bits. So total, so in 2 byte instruction, the representation, symbolic representation is move immediate A, 32H. So here the opcode is move immediate, operand is A, 32H. For hexacode, it generates two hexacode. For one operand is A for 3, another the operand data is 32. So here the binary code, it represents 3 for 0011 for 3, E for 14 1110, then 3 for 011 and 2 for 0010. So this is 2 byte instruction. So 2 byte instruction, simply we call it as 8 bits indicate opcode, another 8 bits indicate operand. And next, 3 byte instructions. Here in 3-byte instruction, the first bit indicates the opcode, and the next 2 bytes, the the first 8 bits indicate the opcode, and the next 2 bytes specify 16-bit address. There are 2 bytes are there, so there are 3 bytes. First bytes it consists of opcode, and next 2 bytes is specifying 16-bit address. Okay, here in 3-byte instruction, LDA 8509, LXI 2500, STA 2600. So all the instructions of 16-bit address are there. So load accumulator 8509. Here in one example, load accumulator 2050. Here the opcode is load LDA, operand is 2050H, the hexa code for 35020. So there are three. One is 8 bits, that is the opcode indicates 8 bit of hexa code, that is 3A. Another 2 bytes are uh, the memory address 50 and 20. Okay, so this is called 3-byte instructions. So this is our conclusion. So all the implied instructions are 1-byte instruction. All the instructions which has immediate data are 2-byte instructions. All the instructions with 16-bit address data are 3-bit. Simply all the register and the implied instruction. The register move A comma B, move C comma A. So these are all the register implied instructions are called 1-byte instruction. Move immediate, that is add immediate A, add immediate, move immediate, subtract immediate. So these are all the 2-byte instructions. LDA, LDAX, LXI 2500, STA 2600. These are all the 16-bit address in the instruction which has 16-bit address. So it is called a 3-byte instructions. Okay. So this is 5 more questions addressing modes and classification of instructions. Thank you.